A warm welcome to all the students. In this lecture, we are going to see a concept known as instantaneous description of a PDA. Now, in the previous lecture, we have seen how a PDA can be designed. But now, how to trace whether a given string is accepted or rejected by PDA. Okay, so instantaneous description is nothing but it is step-by-step execution of a push-down automata on an input string. Okay, and there are basically three components here in instantaneous description. The first component is you have to specify which is the current state. Second component, what is the input that is not yet read or remaining to be read. And third, what are the contents of the stack from top to bottom. Okay, for example, if let's say consider the string say 0 0 0 1 1 1. This is a string that is given to us. Okay, and we need to find out whether this string is accepted by the PDA or it is rejected by the PDA. As you can see here, this is the same PDA that we had designed in the last lecture. Okay, it's a PDA for the language L equal to 0 raised to n, 1 raised to n, such that n is greater than or equal to 1. Okay, so I will be now using the same PDA that we designed in the last lecture to trace this input. And for tracing this input, we will have to design an instantaneous description. Okay, now let's design the initial state. I said in instantaneous description there are three components. The first is the current state. Now what is my current state initially? It is Q0. Now when you are in the initial state, have you read any input yet? No, you have not read any input. So what is the unread input or what is the input that is not yet read? Of course the whole string, because not a single character from the string is yet read. So I write the unread input, which is the whole string. Okay, and third, the content of the stack from top to bottom. As you know, initially the stack is empty. So when stack is empty, it contains only one token, that is Z0. Okay, now from this state, okay, now the first element that is encountered in the input string is 0. Correct? The first element that is encountered in the input string is 0. So now you have to see the automata and check from state Q0 on reading 0, what is the operation that is performed. The first thing is from Q0 on reading 0, okay, and when the stack is empty, that time the 0 is pushed onto the stack. Okay, so as you know, the third component of the stack is nothing but it is the entire content of the stack from top to bottom. It is not the current topmost element. Okay, this third component means what is the current state of the stack, all the elements that are there in the stack, you are just specifying. Okay, so from state Q0 on reading 0, when the stack is empty, what happens? You, okay, go to state Q1. How do you go to state Q1? Okay, by doing what? By pushing this 0 onto the stack. So the current content of the stack will be 0Z1, 0Z0. This is the current content of the stack. And now that this first 0 is already read and it is now in the stack, what is the remaining unread input? 2 zeros and 3 ones. So that I will be writing here. 2 zeros and 3 ones. Okay, now so we have already seen what happens when this 0 is read. Now let us see what happens in state Q1 when another 0 is read. Let's see what happens. Okay, now here it says if you are in state Q1, if 0 is read as input and that time stack top of the stack also contains 0, then you simply push this 0 onto the stack. Okay, so what do you push inside it? 0 0, as you know, the push operation that we have already seen in the last lecture. So when the input symbol read is 0 in Q1 state and topmost element of the stack is also 0, what we do? We pop the topmost element of the stack out, concatenate it with the input symbol, thus forming 0 0 substring, and that 0 0 is pushed onto the stack. So now you are in Q1. When 0 is read as input, what happens? Okay, at the end of this, it's a self loop. At the end of this particular transition, you remain in Q1. So from Q1 state, after doing the transition, you will come back to Q1 state. Now, when you reach this Q1, the next state, okay, this input must have already been consumed. So what is unread will be 0, 1, 1, 1. Okay, so what I will be writing here is 0, 1, 1, 1. Okay, now how this 0 was consumed? As you know, this 0 was pushed onto the stack. So what will be the current content of the stack after this 0 was pushed into the stack? The stack will look like 0, 0, Z0. Okay, always remember, you are visualizing the stack in this manner. Z0 will be the bottommost element, 0 will be the next element, and the topmost element will be also 0. So you are just visualizing the stack. Okay, so this actually is the meaning of it. It is not just the topmost element of the stack. Okay, so with this, let's proceed. Okay, so it is 0, 0, Z0. Then again in Q1 state, when another 0 is read, what you do the same thing. In Q1 state, when another 0 is read and 0 is on top of the stack, see here, 0 is still on top of the stack, what happens? You push that 0 also onto the stack and you remain in Q1 state itself. So from state Q1, on reading another 0, and when the topmost element of the stack is also 0, what happens? You go to Q1 state. Okay, and after pushing this 0 onto the stack content will be 3 zeros followed with Z0. Okay, the stack content will be 3 zeros followed with Z0, and once this 0 is already read, what remains is 3 ones which are unread yet. So what will remain is 3 ones. Okay, further, now in Q1 state, when 1 is read as input and top of the stack is 0, what happens? So in Q1 state, when 1 is read as input and the topmost element of the stack is 0, you pop that 0 out, right? That means you cancel that 0 with 1. That's what we say. So you pop this 0, which is the topmost element of the stack, out, and you push null. And by doing this, you go to Q2 state, correct? So from Q1 state, you are going to Q2 state. After consuming that single one, what will remain is 2 ones. And after cancellation effect, the topmost 0, this 0 would have been removed. So what will remain in the stack will be 2 zeros and Z0. Right? Now, again, in Q2 state, when 1 is the current input symbol that is being read and 0 is the topmost element, what will happen? In Q2 state, when 1 is the current input symbol, 0 is the topmost element of the stack, again this 0 will be popped out of the stack and you will remain in Q2, right? So you will remain in the same state Q2. Okay, this 0 will be popped out, that means this 0 and this 1 will get cancelled. So what is unread now? This one is already read, so what remains is a single one. And after cancellation or after popping out the topmost 0, what will remain in the stack is 0 Z0. Right? Now you are in Q2 state. And in Q2 state, when 1 is encountered at the input symbol and the topmost element of the stack is 0, what happens? So in Q2, when 1 is encountered at the input symbol, 0 is the topmost element, again that 0 is popped out and you remain in Q2 state only. So what will happen here? You will remain in Q2. Now after consuming this single one that was remaining, there won't be anything else remaining to be read, and when there is nothing else remaining to be read, what is read? Null. That means this null symbolizes that the string is already read. There is nothing else remaining to be read. Okay. Also, after cancelling out this 0 with this one in the previous transition, stack would also be empty. So what will be there in the stack will be Z0 only. Now when you are in Q2 state, when nothing is remaining to be read and stack is also empty, then what you do? In Q2 state, when nothing is remaining to be read and stack is also empty, then what you do, you perform no change operation and you just go to Q3 state. That's a final state. So what you do, you go to Q3 state, that's a final state, and since the operation is no change operation, Z0 which was on top of the stack, Z0 still remains on top of the stack. So this, what I have drawn here, this is called as instantaneous description of the PDA. This instantaneous description helps us to understand how the string is traced. Okay. In the previous example, in the last lecture, I was drawing a PDA and I was showing you in a step-by-step manner. In a compact fashion, this way also you can trace any string. Okay. This is just for us to understand what is happening, and we are just tracing the input. Right. So since we reach Q3, that's a final state, stack is also empty and there is nothing else remaining to be read, we say that this string 000111 is accepted. Therefore 000111 is accepted. Okay, so this is basically instantaneous description. So now whenever, for example, they are going to ask you to design a PDA, you will have to design a PDA, and then they might ask you to trace a given input string. So while tracing the input string, you will have to make use of instantaneous description, ID. We are asked to design a PDA for the language L equal to A raised to n, B raised to 2n, such that n is greater than equal to 1. Okay, so before we start, okay, we have to first identify what kind of language this is. Okay, now suppose n is 1, then what is the valid string here? A, B, B. Okay, when n is 1, you will have single A and 2 B's, because 2 into 1 is 2, so you will have 2 B's. When n is 2, you observe that you will have 2 A's and 2 to the 4 B's. Right? When n is 3, you will have 3 A's and 3 to the 6 B's. So in general, when you observe, okay, whenever we have 2 into some n, okay, we are actually having pair of values. Now since n is 1 here, we have a single pair of b. Now when n is 2, okay, for every a you have a pair of b. So since n is 2, you will have 2 pair of b's. Okay, 2 pairs. Here pair equal to 1. Similarly, when n is 3, okay, you will have 3 pairs of, so here you will have 3 pair of b's, and each pair corresponds to each a. So for this a you will have this pair, and for this a you will have this pair. Okay, the first observation is this. Okay, so every a, okay, whichever string that is accepted should be such that for every a there should be a matching pair of b's. Okay, now second observation is that only after all a's are exhausted, then b's would start. So the placement of a's and b's is also important. Okay, so now how should we start? As I have always told you, whenever you are going to design a PDA, first you need to think, if manually I was supposed to solve the problem using a stack, how I would have solved the problem. Okay, now initially, suppose this is the stack that is given to us. Initially Z0 is the topmost element of the stack, and assume that you are in the start state or Q0 state. In the input state, a valid input string that is given to us, it's say 2 A's and 4 B's. Okay, now whatever I have depicted here, the initial state of PDA, the same thing I am going to draw in a graphical manner in the graph structure. So let Q0 be the initial state of PDA, correct? Now in initial state, okay, in the initial state, that is Q0, the stack is empty and the input string given to us is AABBB and nothing is read yet. Okay. Now what method I am going to use? So first thing what I will do is, no matter how many A's are encountered, as many number of A's are encountered, I am just going to push all the A's onto the stack. Okay. Now, so in Q0 state, when the first A is encountered, that time the stack will be empty. Stack will contain Z0 on top of it, right? So whenever I am in Q0 state, when the first A is encountered and top of the stack is Z0, that means stack is empty, what I am going to do? I am going to push the A onto the stack. And for pushing A onto the stack, I will have to pop Z0 out and concatenate it to the current input symbol. So the string that I am going to push is AZ0. Of course in the reverse manner, but the string that I am going to push is AZ0. So what I am going to push? AZ0. And by doing that, I am going to the next state, that is Q1. So when the first A is encountered, I am going to push this A onto the stack. Okay, I am going to push this A onto the stack, and the pointer will then point to the next A. The first A is already onto the stack, and by doing that, from Q0 state, that is idle state, I am going to the Q1 state. Now as I have told you, as many number of A's are encountered, I am just going to push. Now for the second A that is encountered, you notice that stack would have already contained one A, the previous A that was added. Okay, so in Q1 state, okay, if another A is encountered and at that time A is on top of the stack, when the second A is encountered and A is on top of the stack, what I will do, this second A also I will put it onto the stack. Okay, so what you are going to push is string AA. Okay, the second A also you are going to push into the stack. So you are, by doing this, you are in the same state. Why you remain in the same state? Because you are going to perform the same operation of pushing no matter how many A's are encountered. So since you are repetitively doing the same operation, you may stay in the same state. So the machine will still stay in the same state. Okay, so 2 A's I have already pushed on the stack. Now my strategy is what? See, for the first A, okay, I will see the first pair of B's. And how I will be comparing this A with the pair of B's? Okay, when the first B in the pair is encountered, no, I am going to ignore the first B. And ignoring the first B means A which was on top of the stack, A will still remain on top of the stack, no change operation. Whereas when the second B in the pair is encountered, this A I am going to cancel out with this B. So this will ultimately mean that for each A, 1-1 pair is going to be matched. Ignoring the first B, cancelling with the second B. Again, suppose there was another A, ignoring the first B, cancelling the second B, and so on. So I am going to use this strategy. Okay. So now, after pushing the second A onto the stack, the pointer moves to the first element, that is B. So when I am in Q1 state, and at that time if B is encountered, the first B that is encountered in Q1 state, when the first B is encountered, at that time what is there on top of the stack? Since it is first B, obviously on the stack there should be A and nothing else. Okay, so when first B is encountered and the topmost element of the stack is A, what I will do, as I have told you, since this is the first pair, okay, since this is the first pair of B that I am talking about, okay, actually there should be another B here, because the valid string that I have taken should be 2 A's and 4 B's. So I have missed this B. Okay, please note there is another B here which I have missed while writing. Okay, please take note of it. Otherwise the string would have been invalid. Okay, now, so I am trying to match the first A with the first pair of B's. So when the first B is encountered, I am going to ignore that first B. This first B I am going to ignore. Ignoring means A which was on top of the stack, A still remains on top of the stack, and pointer simply moves to the next. Okay, so when the first B is encountered, and that time suppose A is on top of the stack, okay, I will ignore B, and A, there will be no operation performed on the stack. So A which was on the top of the stack, A still remains on top of the stack, and I will go to Q2 state. So what I do is I ignore this B, and the pointer simply moves to the next B in the pair and machine moves to Q2 state. Agreed? Now in Q2 state, when the second B in the pair is encountered, now this B will cancel out with this A, which ultimately would mean that entire pair is now matched with this A. Okay, so when you are in Q2 and when another B is encountered, the second B in the pair is encountered, that time A is on top of the stack, then what I do, this A I cancel with the second B. So cancelling means A will be popped out, and popping out anything means pushing null. Okay, this B I am going to cancel out with this A, and cancelling out means I will just pop this A out and the pointer will increment by 1. That is called as cancelling. So by doing this I will come back to Q1 state. Okay, so now what will happen, this B gets cancelled with this A on top of the stack, so the A which is there on top of the stack will be simply cancelled. Fine, that means what I have done, I have matched this A for this pair, and after doing this operation the pointer will move one position to the right. Okay, and by doing that I will come back to which state? I will come back to Q1 state. Right? Now when I am in Q1 state again, when the first B in the second pair is encountered, this is the second pair, first B in the second pair is encountered, what I do? I simply ignore this B, that means A which was on top of the stack, A still remains on top of the stack, and from Q1 I go to Q2 state. So what will happen? I will move to Q2 state by ignoring the first B. Okay, by ignoring the first B, and the pointer moves to the second B in the pair number 2. So this is pair number 2, this is pair number 1, second B. Okay, now in Q2 state again, when I am in Q2 state, if B is encountered, this is the second B in the pair, and A is on top of the stack, B will get cancelled out with A, and cancelling out with A means A will be removed from the stack and pointer will increment by 1. Okay, so when B is current input symbol, this B happens to be the second B in the pair, this B happens to be the first B in the pair, which is to be ignored. Second B in the pair should be cancelled with this A. So when B is the input element, second B in the pair is encountered, stack contains A, then this B and this B gets cancelled, this B and this A gets cancelled. It means A is popped out of the stack, and as a result of pop operation, what do you push? Null, and you go to Q1 state. So one thing you realize, why Q1 is important. Q1 is a state where you are going to reach only after ensuring that for each A you get one pair of B. Okay, for every A, after matching a pair of B, you are going to reach Q1 state. Okay, so after doing this, okay, so what we did, the first B we ignored, and now in Q2 state, I am in Q2 state, when the second B is encountered, what I will do, I will cancel out this second B with this A, that means A will be popped out, and the pointer here, okay, will be incremented by 1. Right? Is there anything else remaining to be read? No. Remember, for the first A, I have matched the first pair, and for the second A, just now I have matched the second pair also. Okay. Now, in Q1 state, when there is, so after doing this, you remain in Q1 state, right? You have come to, from Q2, you have come to Q1 state. In Q1 state, when there is nothing else remaining to be read and stack is also empty, what it means? That means there is no more matching that is required. That means so far whatever is matched happens to be the accepting string. So you should go to the final state. Okay, so when you are in Q1, and when there is nothing else remaining to be read, stack is also empty, you perform no change operation, that means Z0 which was on top of the stack, Z0 still remains on top of the stack, and I go to the halting state HA, which means that given string is accepted. Fine. So this is how the PDA is designed. Okay, if you design a instantaneous description, okay, for a string, for example AAA, BBB, BBB. Okay, so if we consider this string, let's see what is the instantaneous description. Initially I will be in Q0 state. The string that is remaining to be read will be 3 A's and 6 B's. Okay, 3 A's and 6 B's, and initially the stack will be empty. Now from Q0, okay, when the first A is encountered, what I will do, I will just push that A into the stack. So I will, from Q0 I will move to Q1 state. Whatever is remaining to be read will be 2 A's and 6 B's. And since this A has been already pushed onto the stack contains A Z0. So what I have done, for the first A from Q0, the machine has moved to Q1 state. Now in Q1 state, when another A is encountered, what I will do, I will push that A also onto the stack, and I will remain in the same state. So after pushing that second A, what will remain is 1 A with 6 B's. And since the second A is already pushed, stack now contains 2 A's followed with Z0. Correct? Now in Q1 state, when another A is encountered, you are going to do the same thing. You will remain in Q1 state. You will push that A onto the stack. So what remains will be 6 B's. And stack will contain 3 A's followed with Z0. Now when you are in Q1 state, when the first B is encountered, you are going to ignore that B and you are going to move to Q2. Okay, so where you are going to move? You are going to move to Q2 state. Okay, since you have ignored B, pointer must have moved to the next input symbol. So what is remaining to be read will be, out of 6 B's, 1 B is already read and ignored. So what remains will be 5 B. And since you have ignored, you have not performed any operation on the stack, stack still contains 3 A's followed with Z0. Fine. Now you are still in Q2. In Q2, when the second B in the pair is encountered, this B you are going to cancel with this A, and you are going to move to Q1 state. So you are going to move to Q1 state. Okay, the B you are going to cancel out with this A. So what remains to be read will be just 4 B's, and the stack also will contain 2 A's Z0. Fine. Again in Q0, when the first B is encountered, what will happen? In Q1, when the first B is encountered, you will go to Q2. What remains to be read will be 3 B's. Okay, and since you have ignored that B which is encountered, stack just contains AA Z0. Further, in Q2 state, when another second B in the pair is encountered, you will come back to Q1 state. What will remain will be just 2 B's, and since A must have already cancelled, what remains is AZ0. Again in Q1 state, okay, when the first B is encountered, you are going to just ignore that first B going to Q2 state, and after ignoring that B, only 1 B will be remaining to be read. Stack also contains the same AZ0. Now when the second B in the pair is encountered, what you are going to do? You are going to cancel out. You are going to move to Q1 by cancelling out this B with the A on the stack. So as a result, there won't be anything else remaining to be read. Stack also will be empty. Now whenever you are in Q1 state, okay, whenever you are in Q1 state, when nothing else remaining to be read, stack is also empty, perform no change operation, and you go to the halting state. Okay, so when you are in Q1 state, you will finally go to the halting state by performing no change operation. So this is instantaneous description for the PDA that we have drawn.